Today I want to look at derivatives of trig functions, and as we saw with logs and exponentials, we're going to see here that the rules themselves are pretty easy, okay? However, it's applying those rules along with the product rule, quotient rule, chain rule that makes it complicated at times, okay? Now, notice the rules that we have listed here. The derivative of sine is cosine, okay? The derivative of cosine is negative sine, okay? Now, there's a nice little way that Mrs. Barbag shows her AP Calc students that I borrow every year that helps us remember it. It's actually really, really easy. If you do sine, cosine, negative cosine, okay? SC, negative S, negative C. The derivative of sine is cosine. The derivative of cosine is negative sine. So what do you think the derivative of negative sine is? Negative cosine. And the derivative of negative cosine would be positive sine. All right? So as you're taking derivatives, you could just follow that. SC, negative S, negative C. And that'll tell you what your derivatives are. Later on, when we do integrals, guess how it works? It goes that way. So I'll bring this back when we do integrals of sine and cosine, but the integral of sine is negative cosine. The integral of negative cosine is negative sine. And we just work up the thing, and it's a cycle, okay? So it's kind of a cool way of remembering these. But let's look at actually using these derivatives with a couple that involve some of the other rules that we've worked with, okay? So here I have the sine of x squared minus 3x plus 5. What am I going to have to use in order to find the derivative of this? I have sine of x squared plus minus 3x plus 5.
Positive cosine?
Well, the derivative of sine is cosine, but what rule am I going to have to use here?
Could we use product rule if we factored it?
This is not a product. This is that. Remember, sine is a function. That's actually a common mistake students will make is they'll start treating it as sine times this.
That's not what I meant. I meant product of x squared minus 3x plus 5. If we factor that into two different binomials.
You could, but that would still be inside the sine. Okay. If this factored, you could do that. But in this case, it actually would be simpler here. Yeah, we need to do the chain rule. So we do need to take the derivative of this polynomial. Since it's already FOILed out for us, it's actually easier to take the derivative like this than it would be to factor. But you certainly can if you want. So if we're using the chain rule here, you guys already said the derivative of sine is cosine. So this would be the cosine of what?
X squared minus 3x plus 5.
Good. X squared minus 3x plus 5. Remember, when you do the derivative of the outer function, the inner function stays the same.
Times 2x minus 3.
Very good. Times, now, here's the chain, times the derivative of the inside. So times 2x minus 3. Okay? It doesn't matter if you write it before or after, it's the same.
Why is it called the chain rule?
Because it's like a derivative linked to a derivative, linked to a derivative, depending on how many functions you have inside of them. I don't know who came up with it. But
I'm just
Because it
looking
just
for a
makes
connection.
the-
Yeah.
It just makes the process that much more complicated.
I think it's kind of like this. You know, you have, remember we wrote it dy dx was dy du dx. And the du is kind of like the link in the chain. And we could actually, if we have another function within the function, it would be like dy du, let's say we had v, and then dv dx. You know, we're linking these together so that we get dy dx. I think that's kind of where that term came from, kind of visually thinking of those as linked together. Okay. Even if that's not where it came from, it works, so it'll help you remember. All right, so good. We got the chain rule for this one, okay? Now, let's look at y equals sine times cosine. All right, what do we have to use here?
Product rule.
Product rule, good. Okay, so sine is u and cosine is v. So what's u prime? Cosine x. V prime is negative sine x. Good. All right, so let's work through this. We have u prime times v plus u times v prime. Okay? So this would simplify down to cosine squared x minus sine squared
Which will
x.
simplify you. Wait, never mind.
Yes, it will.
Will? Okay, so 1.
Not 1.
But like a
That would be if it
negative
were plus.
Negative
1
1?
minus.
No, that would be if it were negative
I know
cosine,
it will,
negative
I
sine.
know it will do something. I just
Cosine squared.
No.
1 minus sine
I'm
squared.
trying.
You could make, okay, here's the deal. And this, guys, I want you to think about, all right, because later on when we set these equal to 0 and we got to solve for x, you can't solve it for x when there's cosines and sines mixed in there, right? So we would have to get it all in terms of 1. Cosine squared I could rewrite as
1 minus sine squared.
1 minus sine squared. So I could rewrite this as 1 minus 2 sine squared x. Or I could also make the sine squared into a
Cosine.
1 over.
1 minus cosine squared. And then that would have been 2 cosine squared, because we distribute the negative, minus 1. All of those are equivalent. We would need one of these two in order to solve it. Does anyone with a really great memory remember what all three of these equal? One of our identities from last year?
Wait a moment.
1 squared.
No.
No, I don't.
It's okay if you don't.
Is it though?
It is, because it's in your formula book. All three of these are the same thing as
Secant.
cosine of 2x. This is your double angle formula.
Oh yeah.
Remember double angle formulas?
Well, you do a very good job.
So,
all of them
I'm hearing you say it, I'm kidding.
yes.
I didn't understand. I just.
So actually the derivative of sine times cosine is cosine of 2x. Okay, if we simplified it all the way there.
Do
But
you have to?
no. It's okay if you just stop at, really for now it's okay if you stop at cosine squared minus sine squared. Later when we go to solve equations, you would have to get to any one of these three that only have one trig function left. Okay. Okay. You could if you had to. Alright. So. Alright, so let's look at this one, sine over cosine. What are we going to have to use to find the derivative of sine over cosine?
The quotient
Inverse
rule.
tangent.
The quotient rule, okay? The quotient rule.
I thought
So,
Everybody can get murked. The first
here's
one is
u and
is
v.
sine x,
So what's u prime then?
cosine x.
Cosine x.
V is going to be cosine x.
So v prime is?
Negative sine x.
Good.
So then, how do you know that?
That was on the first slide. That's our rule that we got to memorize for this section. Okay? And those are the only two you got to know. All right?
Okay. Alright,
So,
the next step.
Quotient rule.
Now it's cosine x times cosine x.
Good.
Put those in parentheses together. Right?
Okay.
Yeah, square them. Minus sine x times negative sine x. All over cosine squared x.
Great. Okay. So what does our numerator come out to?
1.
It actually comes out to 1. Yeah, because minus sine times negative sine is plus sine, right? So we have cosine squared x plus sine squared x all over cosine squared x.
So it's 1 over cosine squared x.
That's right.
But hold on, guys.
Wait, why
Here
is it
comes the
1?
kicker.
Hang on.
You can take it even further.
Hang on.
Oh.
Pythagorean identity. Sine squared plus cosine squared equals 1. That's one of our trig identities we got to know.
Okay.
I know it's been 2 years for you, so
Oh my
we'll
god.
have to review them a bit. Okay?
Where can we find them again?
You could find them. You can go back to our pre-cal honors notes. I have them posted.
I did.
Or they are in your formula booklet. The Pythagorean identities are in your formula booklet under the trig.
I know. Do you have the formula books, or you just go through it?
I have formula books here, or you can just, if you Google IBSL math formula booklet, you can find it easy. So, all right, so next what?
Hold up, ladies. We can
Oh my
take
God.
it even further, and we can
Yeah.
simplify that or change it to secant squared x.
That's right. 1 over cosine is secant, so 1 over cosine squared is secant squared. So the derivative of sine over cosine is secant squared.
And tangent too, I'm guessing? Like, it's the same thing. If we did the derivative of tangent.
What did we just find? Yep. What did we just find? We found the derivative of tangent. Because sine over cosine is tangent. So guys, here's the thing. You do not have to memorize the derivative of tangent or cotangent or secant or cosecant. But using our identities, we could very easily derive all of those. Okay? Using the quotient rule. All right? So the derivative of tangent is secant squared. Okay?
Bet you're all impressed. How you like me now?
We can derive these other ones as well. Let me show you here.
What was the answer? Secant squared x.
All right, so let me show you here. We'll take a picture of this because we already did this one here. Okay? And we'll do one of the other ones, so we'll have both of them in the notes. Okay? All right, so with cosecant, you can see here it's 1 over sine. Okay? Which is the same thing as sine to the negative 1. I put the negative 1 out here so I wouldn't confuse it with arc sine. Okay? But then we use the chain rule. Negative 1 times sine to the negative 2 power times the derivative of sine, which is cosine. Okay? So now when I put those together, I have a negative cosine over sine squared. And this is where we kind of played with it to make it look like you're going to see if you look it up in a formula booklet or something. I split it up into 1 over sine times cosine over sine. So I split up the sine squared. And I made it multiplication here. Okay? So it's negative 1 over sine, which is cosecant, times cosine over sine, which is cotangent. So the derivative of cosecant is negative cosecant times cotangent.
I don't like this.
Sorry.
Wait, do we have to simplify it that far?
Well, unless you were told, this is where you might be told, show that the derivative equals this. Okay? Just like on the next one, we could say, show that the derivative of secant equals secant x times tangent of x. So let's actually do that. All right? secant is the same as 1 over cosine, right? Which is the same as cosine x to the negative 1. Okay? So if I'm taking the derivative here, I have to use the, what rule? Chain rule, all right? So negative 1 times cosine of x to the negative 2 power times the derivative of cosine. What's the derivative of cosine? Negative sine. Okay? So we have two negatives that end up canceling out. So now I have sine of x over cosine squared. And this is where you'd have to think, okay, how would I get from there? If you were just told to find the derivative, you could stop there and that would be totally understandable. Okay? But since we were told to show that the derivative equals this, we'd have to think, okay, well, I need a secant. A secant is 1 over cosine. So I'm going to have to split this up so there's a 1 over cosine x. And if I do that, 1 times sine would give me sine, and cosine times cosine would give me my cosine squared. So that's where I get the secant times the tangent. Okay? So, the derivative of cosecant is negative cosecant times cotangent. The derivative of secant is secant times tangent. Okay? And they're actually related a little bit here. Okay? Or there's kind of a pattern to it once you look at it. For cotangent, we would do that the same way we did tangent. Okay? Or, actually, let's put together what we know.
Are we going to use the quotient rule for cotangent?
We could, or
Where else can we use?
so can someone tell us what else we could do to find the derivative of this?
You can use the tangent, 1 over tangent.
Yeah, this is 1 over tangent, so tangent of x to the negative 1. Since we just found that tangent, what tangent was, we could go ahead and use that here. Again, you're not expected to know it, but I could do it. dy dx is negative 1 times tangent to the negative 2 times the derivative of tangent. Well, if you look on the back on the last page there, what's the derivative of tangent? Secant squared.
Wait, how did that happen?
From the last slide. Okay?
What was it? Wait.
The last slide we did the derivative of tangent.
Yeah, we did secant square that.
Yes.
Oh, right.
The derivative of tangent
424.
was secant squared.
Yeah, but if we don't know that, we have to extra argument.
You would have to, okay?
Because if you're not going to remember that tangent.
But that's okay. Yeah, you would, if you were doing it, you would probably use quotient rule. I just wanted to show you there's a lot of different ways that you could handle it, okay? Either way, guys, your final answer here, you'd get dy dx equal to a negative cosecant squared x. Okay? Which is kind of cool because tangent gave us a positive secant squared. Cotangent gives us a negative cosecant squared. So like the cos pair together and all the cos end up negative. All the non-cos end up positive. And they kind of pair together. So there's a pattern. All right, see you guys.